So here you can see a fixed beam is there, span 9 meter. Okay, a fixed beam of span 9 meter. So at 3 meter, 120 kilonewton load is acting from A, and 6 meter, 180 kilonewton load is acting from A. Okay, so those points are C and D. So this is C point and this is D point. Okay. So what is the first step? We have to remove the fixed support, and we have to introduce one reaction RB and one moment MB. That means here clockwise movement. Okay. So first we have to draw the bending moment diagram for RB. So remove the external load. So remove the external load and remove this MB. Apply only RB. So the force into perpendicular distance. What is the perpendicular distance? 9 meters. So the overall span is 9 meters. So RB into 9. Okay. So this is the bending moment diagram. Since RB is a point load, a reaction load, so the bending moment diagram will be a triangle. Okay. So what is the corresponding centroid distance? So since it is a triangle, the centroid distance is 2/3 of L. 2/3 of L. So therefore, 2/3 of 9 equal to 6 meter. So this is the first diagram. Second diagram is we have to draw for the moment, and the third diagram we have to draw for 120 kilonewton, and fourth diagram we have to draw for 180 kilonewton. Okay, so you can see here. So the second diagram is bending moment diagram for MB. So if moment is acting directly, the bending moment diagram is a rectangle. Okay, it's a rectangle. So what is the corresponding centroid distance? It is B by 2, so 9/2. So overall span, that means length of that bending moment diagram divided by 2 is 4.5 meter. Okay. Next, coming to third diagram. So third diagram, we applied load acting at D point. That means 180 kilonewton. Bending moment due to 1. So here under this portion only load is acting at the D point. Okay. So 180 into corresponding distance 6 meter. So we got the bending moment value 1080. So the centroid distance, since it is a point load, the bending moment diagram will be a triangle. Okay. So the coming to centroid distance. So centroid distance up to D is 2/3 of 6 meter. So this length is 6 meter. Okay, from here to here. From here to here, it is 6 meter. So it is 2/3 of L, plus we have to add this additional 3 meters. So we need a centroid distance from B. So 2/3 of 6 meter plus 3. So it is 7 meter. Okay. So next we have to apply 120 kilonewton and find out the bending moment diagram. Okay. So 120 into 3, we got 360. So again, we have to calculate the centroid distance from B. So x4 is equal to, so first we have to calculate up to this point. It is from here to here, it is 2/3 of 3. This is 3 meter. 2/3 of 3. We are applying 2/3 of 3 plus, and this additional length from B is, it is 6 meter. Okay, 6 meter. So 2/3 of 3 plus 6 meter equal to 8 meter. So next we need to calculate RB and MB. So there are two unknowns are there. So we have to apply the first compatibility condition. That means A is equal to 0. Area of bending moment equal to 0. And the second compatibility condition, that means A x bar equal to 0. Okay. So first A is equal to 0. So we have to calculate all the bending moment area. Bending moment diagram area, which is equal to 0. So what is the first bending moment area? It is nothing but half into B into H. So half into 9 into RB. This is for reaction. And the second bending moment area is this one. This is second. So breadth is 9, height is MB. So 9 MB. Next minus third bending moment diagram. So half into B into H. So this is B and this is H. Okay. Next fourth one half into B into H. This is B and this is H. Okay. Which is equal to 0. So simplify all the equation. We got 40.5 RB minus 9 MB equal to 3780. So coming to second compatibility equation, A x bar equal to 0. So area we already found, you can see 9 MB and 3240 and 540. So we have to multiply the corresponding centroid distance to that each area. Okay, so that centroid distance we already noted in the diagram. So simplify, multiply and equal, we got the second equation. So now this is first one, this is second one. Okay, so equate these two equation and solve. We got RB and MB. RB and MB. So two values we got. Okay. So next coming to RA and NA. So we need to calculate RA and NA. For that, we have to draw the free body diagram. So this is your free body diagram. Okay. So what is the reaction RA? RA plus RB is equal to total load. Here what is the total load? So total load is 120 plus 180. 120 plus 180. Okay. So what is 120 plus 180? So it is 300 kilonewton. So 300 minus RB. RA plus 164.4 plus 300. Then RA is equal to 300 minus 164.4. So we got 135.56 kilonewton. This is your RA. Okay. So next MA. So for that MA, we can see this is the anti-clockwise direction, and we have to take the moment about the point A. Okay. So we have to calculate the moment at point A equal to 0. So minus MA plus 120 into 3 plus 180 into 6. Okay. So next this reaction. So you can see these are all clockwise. Clockwise one. You can see this point towards are clockwise. And next coming to this reaction. This reaction. What is this reaction? This goes into this perpendicular distance. So it is anti-clockwise. You can see here it is anti-clockwise direction. This is anti-clockwise direction. So we have to put minus. Okay. Next, here 320 kilonewton meter is there. ETC is the clockwise direction moment. Clockwise direction moment. So plus 320. Okay. So finally we have MA is equal to 280 kilonewton meter. Okay. So from this reaction, that means RA is equal to 135.56 and RB is equal to 164.4. We can easily calculate the shear force diagram. So 135.56 minus 120. Okay, we got 15.6. Again, minus 180 at the point D. At C points 130 kilonewton, at D point 180 kilonewton. So we got minus 164.4 kilonewton. Same answer we got. Okay, so this is the shear force diagram. Next, coming to bending moment diagram. So we calculated only two bending moments. That means MA and MB. What about bending moment at C and D? So now taking moments about the point C. Okay. So minus 280. Minus 2. Actually, MA is the anti-clockwise direction moment. So minus 280 plus that RA into 3. 135.56 into 3. So we are considering. You can see here we are considering. For this bending moment at C, we are considering only left side, okay, for easy calculation purpose. So minus MA then RA into 3. That's all. Next come to 180 kilonewton point. Okay, again same. Minus 280 plus RA into 6 meter. RA into 6 meter. Next minus. So here you can see additionally we have to subtract this 120 into 3. So this 120 into 3. So we are taking moment about the point D. So we are considering only the left side. Okay, so we have to include all the loads moment. So 120 into 3 is the anti-clockwise direction. So that it is minus. So from this we calculated it is 173.36 kilometer. So therefore, bending moment at C point is 126.7. Bending moment at D point 173.4. So from this you can draw the bending moment diagram. That's all. So this ME and MB are the negative bending moment, and this 126.68 and 173.6. That means bending moment at C point and D point are the positive moment. So this is the next problem. A fixed beam of 5 meter length. Fixed beam of 5 meter length. Shot 2 meter from the left end A. A uniform moment. That means a clockwise moment is acting. So what is the intensity? 500 kilonewton meter. Okay. So whatever be the load, you don't bother about the load or moment, whatever may be. Okay. So the steps and procedures are same, whatever be the load. So what is the first step? So here remove the support B and apply RB and MB, a clockwise movement. Okay, this is the first step. Okay. So next, as usual, draw the bending moment diagram. So here we have to draw 3 diagrams. First one is for reaction, a triangle bending moment. Second one is a moment, a rectangle bending moment. And third one is a clockwise moment. So a clockwise moment means a rectangle one. Okay, since it is a moment, the bend for moment the bending moment diagram will be a rectangle. Okay, so here you can see the length of the beam is 5 RB. So sorry, 5 meters. So RB into 5. Next corresponding centroid distance 2/3 of 5. Next moment is acting. So in this moment value MB and corresponding centroid distance is 5/2, 2.5 meter. So next coming to external moment, the intensity of moment is 500 kilonewton meter. So the height of that rectangular bending moment diagram is 500 and the corresponding centroid distance is 3 meter plus 2/2. So actually from here to here, what is the distance? It is 2/2 only. Okay. So because the moment is acting at 2 meter, so the full length is 2 meter. The half of this 2 meter is 1 meter. Okay. So this is 1 meter. So 2/2. So plus from here to here it is 3 meter. So we have to add that also. Okay. So next, as usual, first compatibility equation. So what is the first diagram area? Half into B into H. Here half and B is 5 meter and H is 5 R. Next, minus 5 MB. Okay, that means corresponding length and height. Length is 5 meter and height is MB. So next, the third diagram area. So 500 into 2 meter. So the distance here you can see they didn't mention the distance of the block. Okay, length of the block is 2 meter. Okay, because the moment is acting at 2 meter from A. So we arrived at the first equation. Next, coming to second equation. So as usual, you can write here same area and the corresponding multiply by corresponding centroid distance. The first centroid distance is 3.33 and the second one is 2.5 and the third one is 4. Okay, so we arrived at the second compatibility equation. Okay, so now you solve these two equations. That means this first equation and this second equation. Solve this two equation. What is the value we got? So we got RB is equal to 144.6 and MB is equal to 161.5 kilonewton meter. So this solve for solving purpose, either you can use calculator or you can do manually. Okay. So once RB, MB we found, what is the next step? We have to calculate RA and MA. So how to calculate RA? So here there is no load. That means RA plus RB is equal to total load. So this point is very, very important. Please note down. This point is very, very important. So RA plus RB is equal to total load. Here load is not given. Then how to find RA? So RA plus what is the reaction RB? 144.6 equal to 0. Equal to 0. Therefore RA is equal to minus 144.6. That means RA reaction is acting downward. Next, summation of moment taking moments about the point A equal to 0. So minus MA, that means yeah, anti-clockwise direction moment plus a clockwise direction moment. You can see a clockwise direction moment plus 500 and here also a clockwise direction moment 161.5 minus this reaction into this distance. So since we are taking moments about the point A, so therefore 144.6 into this force into corresponding distance. So what is that distance? It is 5 meter. It is anti-clockwise direction. So therefore MA is equal to 61.5 kilonewton meter. Okay. So therefore, what is the corresponding shear force diagram? So shear force diagram is nothing but a rectangular diagram only, 144.6 because both side reaction is same. So 144.6 kilonewton. That is a shear force diagram. Next, coming to bending moment diagram. So the corresponding bending moment MA equal to 61.5. Okay. So at C point, so you can see here at C point only moment is acting. Okay. So at this point, the bending moment value will change. So therefore, MCL, what is MCL means? Bending moment at C point, left side. MCR means bending moment at C point, right side. Okay. So that means before acting, find a kilonewton meter, that is left side. After acting, find a kilonewton meter is the right side. Okay. So now you can see here 61.5. So consider before 500 kilonewton meter at C point. So 61.5 is the moment at A minus 144.6 into 2. That means RA into 2, which is equal to minus 227.7 kilonewton meter. Next, bending moment at C point right means, so same value you write. For that only they taken minus 227.7 kilonewton meter. That means minus MA 61.5. Next, actually this 61.5 is minus and this 144.6 into 2 is the plus. Okay, because it is acting anti-clockwise and RA into 2 it is clockwise. Actually they changed the sign convention, please note down. So same value you write minus 61.5 for MA and plus 144.6 into 2. Okay, up to the C point plus include this 500 kilonewton meter clockwise moment. This is for after the moment acting point. That means right side. So we got 272.3. So plot all the values. So you can see here moment at A 61.5 and at C point. So this is C point. At C point, before 500 kilonewton meter moment acting, it is 227.7, and after moment acting, 500 kilonewton meter acting, it is 272.3 kilonewton meter. Next, MB value is 161.5 kilonewton meter. So this is your bending moment diagram. Next, how to calculate this point of contraflexion? Okay, you can see this diagram for calculating x1 and this diagram for calculating x2 by using similar triangle principle. Okay, similar triangle principle. So now you can see here x1 divided by 2 minus x1. So x1 divided by that is CD distance. That means this CD distance is 2 minus x1. 2 minus x1. Okay, x1 divided by 2 minus x1. So x which is equal to 61.5 divided by 227.7. Okay, you can see here this value. So for x1 it is 61.5, 2 minus x1 it is 227.7. So from this we can easily calculate at the x1 values. Okay, we can easily calculate x1 value. That means this is the point of contraflexion point in that bending moment diagram. It is 0.43. Okay, so next come to x2. So same thing. So x2 divided by 3 minus x2. Okay, because this distance is 3 meter. Okay, so x2 divided by 3 minus x2, which is equal to 161.5 divided by 272.3. Okay, so x2 divided by 3 minus x2, which is equal to 161.5 divided by 272.3. So solving this equation, we got x2 is equal to 1.12 meter. So you can see the corresponding length of the point of contraflexion. Okay, so x1 equal to 0.43 meter, x2 is equal to 1.12 meter. Okay, students. So up to this problem is over. So if in the fixed beam, if moment is acting, it is we can easily solve because for moment condition, the bending moment diagram is a pure rectangle only. So no triangle, no parabolic. So we can easily solve. Okay, student. Is it clear, students? Any doubts means now you can ask me. Student, please go through. Any doubt, ask me. So today we seen only two problems. Okay, so don't join after closure of this meeting. That means after 40 minutes. Okay. So today we will discuss the two problems only. So next class we will discuss about sinking of supports. Suppose in a fixed beam, suppose one support is deflected, one support is sinking. So what happened? What is the effect of sinking in the moment? That we will discuss in the next class.